Modifying a subset of rows in a pandas data frame. Assume I have a pandas data frame with two columns, A and B. I'd like to modify this data frame, or create a copy, so that B is always nan whenever A is 0. How would I achieve that? I tried the following. And? Without success.
Use .log for label-based indexing. The df.a=0 expression creates a Boolean series that indexes the rows, B selects the column. You can also use this to transform a subset of a column, for example. I don't know enough about pandas internals to know exactly why that works, but the basic issue is that sometimes indexing into a data frame returns a copy of the result, and sometimes it returns a view on the original object. According to documentation here, this behavior depends on the underlying NumPy behavior. I found that accessing everything in one operation, rather than 1-2, is more likely to work for setting.
Here is from Pandas docs on advanced indexing. The section will explain exactly what you need. Turns out df.log, as 9 has been deprecated, as many have pointed out below, can be used for cool slicing/dicing of a data frame. And it can also be used to set things. So Bren's answer is saying find me all the places where df.a=0, select column B and set it to np.nan.
Starting from pandas 0.209 is deprecated. The right way is to use df.log. Here is a working example. Explanation. As explained in the doc here, .log is primarily label-based, but may also be used with a Boolean array. So, what we are doing above is applying df.log row_index, column_index, I. Exploiting the fact that log can take a Boolean array as a mask that tells pandas which subset of rows we want to change in row_index. Exploiting the fact log is also label-based to select a column using the label B in the column_index. We can use logical, condition or any operation that returns a series of booleans to construct the array of booleans. In the above example, we want any rows that contain a 0, for that we can use df.a=0. As you can see in the example below, this returns a series of booleans. Then, we use the above array of booleans to select and modify the necessary rows. For more information, check the advanced indexing documentation here.
For a massive speed increase, use NumPy's where function. Setup. Create a 2-column data frame with 100,000 rows with some zeros. Fast solution with NumPy.where. Timings. NumPy's where is about 4x faster.
If you want to see more, please consider subscribing.